live from New York, it's Ask It Engineers.
Hey everybody, welcome to another fantastic Ask It Engineers. I'm Lady Ada, the primary engineer, and this is Todd, secondary engineer.
Lesser engineer.
No, not lesser, just on deck.
Right.
Todd's with us.
Clean up.
He's got you're analog and digital. You're like mixed signal.
Yeah, I am mixed signal.
He's a mixed signal kind of man, and he's looking. So, welcome to an exciting show. We'll be showing off all sorts of cool video projects. You were just at Maker Faire showing off your stuff. So if you went to Maker Faire New York, you might have remembered his fabulous smile and his really strong H-sync and V-sync.
Yes.
Great sync there. You really color burst it like.
I have colors for days.
Super tight. All right. And Phil.
I'm
camera
Phil.
control.
I'll be running camera control, all the things on Twitter and on Google+.
The actual engineer.
And everything else, yeah.
Yeah, and I'll be giving out the discount code tonight.
Yeah, so be nice.
On tonight's show, we'll be talking about the show and tell. We had a fantastic night filled with lots of folks. We'll tell you how to join the show and tell every week. Our special guest is Todd Bailey. We've known Todd for a long time. We'll talk about all his cool projects and more. And what this thing is. Whoa. Talk about some big news in the world of open source hardware and Arduino. Packet the Mailbag will stop by. There's Packet. He reads their mail that we get. Yeah. We got some news from the Adafruit Learning System, some new tutorials. Wearable Wednesday. A little bit of news on 3D Thursday. New products. We'll answer your questions. We'll have a trivia question. All that and more on Ask an Engineer. All right. Oof, big show. Okay.
Epic.
Welcome, Todd.
Hey.
It's good to have you on the show.
Hey.
One of the things we saw Todd at Maker Faire, and we said, okay, we're always so busy, we'll just figure out a way to hang out. So it's Ask an Engineer now. Yeah. So you've seen Adafruit grow. We've known you for, I don't know, maybe 10 years, right? It's close
no,
to
5 years.
5 years?
5 years.
I wrote about you in 2006.
Yeah, no,
it's
been more than that.
Yeah.
It's been more than that. I met you at iBeam.
Yeah, you and me and Ivan fight like it's like 5 years ago.
Yeah, and I wrote about Todd in 2006 for sure because I have a post. But it's been neat because there's only a few people that we've known for this period of time as Adafruit moved to New York and grew and stuff. So it's always nice to be able to keep in touch. And we said, yeah, we have to figure out a way to hang out. So thanks for coming on the show.
My pleasure.
Yeah. Tonight's code is PowerGauge, 10% off everything in the Adafruit store that's in stock. Code PowerGauge. Use it on checkout, 10% off. All right. One quick programming note: if you hear a ham radio going off in the background, what is that, Todd? What's going on over there?
What is going on over there?
Yeah, I have a. So I was like, you guys can ask actual questions, or via the information superhighway, or you can ask via the ancient superhighway, the lesser highway, the dirt road, via ham radio. So I'm tuned into WA2 WCB repeater on some building here in Manhattan. So you can ask questions via the WA2 WCB. Repeater, or if you happen to be in the area very close by, you can hit me on Simplex at 446025. 82DZO.
And one OUE. That's me.
Oh, I didn't know. Well, all right.
What? Yeah, throwing all down, call sign down,
You're not on the handbook?
and I'm not cool anymore.
Are you in QRZ?
No, I don't think so.
All right.
I didn't pay for anything. That's the deal. Like I got my techno code, and I'm just like, I'm done. I was like, that's $70. I'm finished. I'm
General
not
class.
Yeah. Whatever.
All right. First up, show
I
and
can
tell.
run one of these.
Lady Ada, tell us about the show and tell.
Okay, we had some fun people on the show and tell, some oldies and goodies, and some repeat customers. We had Tony come back. This time he's making a creepy Halloween skull, and he's using open frameworks to do facial detection. And then he has like his animated skull that stares at you and reminds you of your own mortality.
It does.
So
it's also kind of like Doom.
It's got a little bit of flaming skull thing going on. Adam showed off a really cool kit. He's learning how to build kits, and he built like a binary counter, and then he like stepped it up and he turned it into a Larson scanner and an epoch counter and a standard binary clock and like a POV toy. This thing was like a 4-in-1 kit.
It was.
Which I kind of like.
There are clock chips that I wish worked as well as that.
Yeah, I liked it. And actually, he's like, I've got 63 more years on this until the next epoch. Noe showed up with his MIDI guitar. This didn't really work last time with the audio, but this time he had the audio channeled right through the mic. So it was an awesome MIDI drum controller guitar.
Ripped madly. Did not do the Chuck Berry duck walk. But still ripped madly.
Yeah, but he's like trying to like speak and like there's a video camera. It's hard. Anyways, the cool thing about it is he made it. It was 3D printed and it was exactly replicator 2 size, so like the MakerBot, it's like has a certain build volume. So he made it out of pieces that would fit exactly into the replicator 2 build volume, which is neat.
Yeah.
This actually wasn't like too small; it was like pretty big, right? But it was like snapped together pieces. So that was cool. Chris Young showed up. He's doing a couple trinket projects. He got hooked up to our I2C LCD backpack, so it's a good time.
Yep.
Mike showed up. He made a window dressing out of
Not Christmas lights.
Not Christmas
No.
lights. A multi-holiday LED bonanza that
Right.
he will program in for different days of the year.
Non-denominational.
I mean, in all denominations. I'm expecting
Right.
Hanukkah lights. I mean, whatever. Like, I'm expecting everything. Sally showed up with a totally snazzy LED hat.
Slammin' hat.
That was a
Good
slamming
looking
Yeah.
hat.
flower hat. I like that project. It's a fun project. It's getting cold here, but we have an Indian summer, so maybe there's a little bit of time left for a hat. And then Alonzo showed up with like a Minty Boost charger kit that he made with his 2 kids that are 10 years old, and then he's going to maybe make them make more kits, and they're going to make lull shields because you get a lot of soldering for your dollar with a lull shield because there's like 95 LEDs that you have
Right.
to solder in. So I can't wait for him to come back with his lull shield LEDs.
All right. Everyone on the show and tell gets a As Seen on the Show and Tell sticker.
It's a lovely sticker.
Lady Ada, how do they get on the show and tell?
Getting on the show and tell is enjoyable, and all your friends are doing it. So join in. Go to the plus page at plus.google.com.
Don't be different.
Don't be different. / plus symbol Adafruit, and go to the post where we say comment here to get added to the show and tell circle, and then comment there, and we'll add you, and then you can show off your project.
Okay.
Isn't that fun?
All right.
Wouldn't that be enjoyable? Wouldn't you love to join all these cool people?
Yeah, it's like a maker fair every week.
It's like a little mini maker fair,
Yeah.
like in your living room.
We're all doing it.
Yeah. All right. So we have a special guest tonight. We've been able to have more guests because we have more equipment now. We have other microphones and everything's been working out. Todd's here. You're visiting from Brooklyn.
I am visiting from Brooklyn.
All the way out from Brooklyn. And I do want you to tell everybody a little bit about yourself. But I remember here's the first time
Oh, jeez.
I wrote about you on Make. The Bling Binary LED watch.
Concept equals.
This was in 2000.
Concept equals
This is in 2006, and I saw this watch and I thought it was the coolest thing in the world. And
That's
then,
a Friendster photo, by the way, that you're pulling up right there.
Yeah,
Wow.
So that's if that helps date it.
still big in Brazil. And this is the watch, and I remember when people would ask me, "What is the maker movement about?" This was one of the projects I would always show. The rotary cell phone that SparkFun had. That was one of the ones, and this one because I thought, wow, someone who's doing this for fun on the weekends. This is what everyone's going to be doing in a few years.
Yeah.
And like, look what's happened with Pebble and really big commercial successes. But the idea that someone can make a watch that does something different than just tell time, or it has technology in it, or it's more fashion. Tokyo Flash.
Yep.
Look at all those things that's come along.
Well, I mean, the cool thing about that watch is that it does just tell time.
Yeah.
That's all it does.
Yeah.
Yeah, so that's how I first saw you, and I thought, wow, this guy's pretty cool. And then
I
since
have
then,
that here.
Yeah, and then since then,
I like how you have the batteries outside of it, so it's like you can replace the battery. It will last.
Well, the whole thing is cast, right? So the whole thing is like when it's done, it's done.
But it's also kind of good because it's
yeah.
also like it won't get damaged. Like it'll run forever.
Yeah. You can, I think, probably open a beer on it, but I haven't yet to try.
so on the introduction on the text, it says you're a Brooklyn-based engineer. So tell us a little bit about yourself, Tom.
So I'm an embedded systems engineer, which means that I work on projects that have to do with small computers, sort of like the stuff that Adafruit sells, but for commercial applications a lot of the time. Which means,
What does that mean?
well, what that means, I started out actually. My degree is in English,
and you speak great English, by the way.
Thank you. I like to think I
Studied
turn
hard.
a neat phrase. And I in college I used to repair amplifiers and stuff like that. My first job out of school was repair. It was an amplifier repair shop in Portland. I never actually. My father was an electrical engineer, and I never had a good concept of what engineers did for real at that point in my life. I just knew that I liked to do electronics. So I would spend my time working in this repair shop, and I designed a lot of little simple oscillators and filters and whatnot, mostly for my crappy rock band. And it wasn't until, fast forward a couple of years and I had learned to program. I had mostly done analog electronics and mostly worked with tube stuff. And I would have these huge giant boards of 4000 series CMOS logic for sequencing things, basically. Like, I would be like, if there was only a way to flip a switch and make more than one thing happen at the same time.
Incredible.
Yeah, I know. It seemed like a big thing to do. And I learned how to program PIC assembly. And it was crazy within
No accumulator.
Yeah, right. That's what I learned later what the term bottleneck was.
Yeah.
And
Also known as the single accumulator.
the single accumulator, the working register they call it.
The working register.
But the crazy thing was that within a small number of months of doing that, I had a job, which is some kind of commentary on something. I'll leave it to the pundits out there to figure out what it was. But I ended up getting a job at a toy invention house in Chicago, and working there for a bunch of years, and it was like getting put through the ringer. We made probably 200 prototypes a year, and I was the primary programmer that was there.
And you would do this under contract, or you would pitch these to toy companies?
So the company's called Big Monster Toys, and I owe them forever for putting me through the ringer and generally being hard on me.
Yeah, they probably underpaid you too.
I'd rather not say, but it was a great place to work for, and they made money by licensing, basically. So either they got, either Hasbro would come to them rarely and say, we need a roller skating Barbie, and all the designers there would come up with interesting ideas for a roller skating Barbie, arguably interesting ideas for a roller skating Barbie, or we would know that there was a hole in Hasbro's,
roller skating
inventory, and we would be like, what they need in 3 days is a roller skating Barbie. And so I spent a lot of time designing Hot Wheels toys and roller skating Barbies and what have you, and it was a great job because of the sheer quantity of stuff that we worked on. We built a lot of things that were really, really technically impressive. A lot of them, like in Raiders of the Lost Ark, where at the end there's like the giant warehouse, and Indiana Jones has gone through all this stuff, and he's like, I brought you this Ark.
Yeah,
and they're
it
like,
just gets mothballed
no
away.
problem, and
Yeah.
it gets stuck in the back.
Yeah.
There's a lot of stuff like that at that toy company, where it's like the most amazing toy you will ever see, and it will never see the light of day.
Yeah.
So
Just because of bad timing or whatever?
For a lot of reasons. I mean, sometimes the most awesome things don't make the best products.
Yeah.
Yeah.
Sure.
And how many products did you work on that made it to the shelves?
I don't know. I mean, I stopped keeping track. Dozens, probably.
Yeah.
Maybe. I have a couple patents on some of them. The best one I made was an RFID toy called Hyperslide, which is for Hasbro. It did not sell particularly well, but it was a great toy. I have a Hot Wheels game about a volcano that eats cars that has persistence of vision in it.
That's cool.
I have a Polly Pocket dancing stage that you dress up little Polly Pockets on, and it plays a tune. It was not the hardest job I ever did.
That's cool. And one of the things I think that's cool about the toy business, which we see this in our world now, you have to get to the lowest possible cost.
Yes.
And it also has to work.
Yes.
Because your customer might be 3 or 4 years old.
Right.
So
Chances are they're
So-
3 or 4.
It will get used.
and on the
And
bill
they
of
will do the stupidest things with it.
Yeah.
in the bill of materials,
It will
or
be-
they'll do the smartest things
It
with
will,
it.
it, will,
Yeah.
it will be peanut butter ruggedized.
Yeah, and the bill of materials, saving a penny is a big deal.
Huge deal.
Yeah.
Huge deal. In that RFID toy, I designed this coil, and I was using this Chinese RFID chip, and which is actually a great chip. It had a terrible data sheet, but it was a great chip. And they wouldn't let me use a transistor amplifier. I was like, can I have one transistor to use as an amp for this chip? And they were like, no, you will solve it without a transistor. A transistor does not cost very much at volume.
It was like a penny or two.
It was a penny.
Yeah,
and they were
literally
like,
a
that penny
penny.
is unacceptable. So we solved it without a transistor.
Okay, well, there you go. And when you I remember you told me once that when you were making these toys, there was often a processor that you would use that was like a kind of a standard processor.
The Toy Brain, the Motorola 68K based dev board. That was like, I learned a ton of that job not just by doing, but also from some of the contractors who worked there. I don't know if you guys
So
remember.
you guys would use like the lowest cost chip available.
No, for prototyping we used fancy.
No, but
chips.
for the final design, what would they would use
Yeah.
custom silicon or what?
No, very rarely would we use custom silicon. We would use chips from General Plus and Sun Plus and WinBond.
Man, General Plus.
Yeah, you know about them?
Yeah, General Plus.
Yeah, And you're like, how do you do a subtract with carry on this?
But you know
turd?
what's fascinating? It's like
Yeah.
General Plus is like, because they make these cameras that I'm looking at. They have an all-in-one HD camera chip.
That's the thing that you find is you find a weird thing.
And
that's
it's like
$7.
$1.
Yeah, that's like 7 cents, and you're
It's like, how did they do this?
and it kind of doesn't work, but it kind of works.
But it kind of works enough.
Yeah,
And you're
right.
like,
yeah.
and you're like, it blinks like 3 times. That's how you know it's in like
Right.
record mode. And
Right,
then you're
right.
like, it's like literally just like, it's like crystal button,
Yep.
and you're done.
Yeah. So we had that
Creepy
experience
stuff.
a ton.
Haltech's like that too. I like their stuff. Super
Yeah.
cheap.
So
But
would you
weird.
say that you're like that the toy experience that got you battle tested, and then because now you do lots of consulting and
Yep.
contracting, is that where you just kind of every possible problem came across and
Well,
challenge came your way?
Ultimately, one of the reasons I left is that no, not every possible problem came across. Like there's a very
Eventually, it's
specific,
a lot of Polly Pockets.
a lot of polypockets.
Yeah, eventually it's like, okay,
yeah.
another thing that you press the thing and it plays the sound.
Yeah,
Like,
exactly.
Eventually you get tired of that.
Yeah, you get tired of it, and you also, when you're a young and idealistic engineer, you're like, I don't know if I want my legacy forever and ever to be a Barbie doll. And it was like it was time to work on other projects. There were sorts of things like no one gave any much of a care about precision at that job, and as a dork, if that's the sort of thing that you care about.
Were
Which
the
it was.
deadlines intense? Because it was like you have to get this done by a certain time
Oh,
for
they were
Christmas.
incredibly intense. Yeah. There was a lot of sleeping at that job.
Yeah. Did you guys have to do through production, or was it one of those things where once you had a pretty good prototype, you passed it on to like Hasbro and they took it to production with their team?
Generally, that's how it worked.
Because they have like a team that's like really good at like we'll port your code to.
They have a bunch of facilities. The manufacturing facilities generally were responsible for doing that. So it went through Hasbro and it got play tested and messed with, and the toy designers put a seal of approval on it. Management put a seal of approval on it, and then it would go to China. It would go to the factory where these things would get made, and they would rip it apart and redesign
Redo
the
it,
whole
yeah,
thing, basically.
redo it.
And occasionally you got roped into doing production, but generally speaking, it was bad for everyone if you did because it was
Yeah.
pulling you off development, and Hasbro was spending money on something they didn't want to be spending money on.
And they had a team, and the team should be doing it.
Yeah.
Okay.
Okay, well, you brought a whole bunch of cool projects, and these are ones that I've seen on your blog. Some of these are the first time I've seen in person. So maybe you can grab them and tell us a little bit about them.
Sure.
Where would you like to start?
We could go chronologically, I guess.
Okay.
So this is the watch. This is in fact probably not the one you saw on the site, but it's close by. Is there somewhere I should put this?
Yeah, we're gonna. Those are robotic 3D printed prosthetics.
Okay.
Move those off to the side. And
here, you-
we'll switch to this.
Okay.
And there you go. Yeah, so you can see it.
So this is the thing. This is a binary watch, right? You've probably seen lots of them. This was my first microcontroller that I ever programmed. It's also the first printed circuit board that I ever laid out, and you can see it's all gummy and messed up. It's also the first plastics casting that I ever did. And it's like technically it's not wildly impressive, right? It's a processor that counts in binary, and it runs at 32 kilohertz, and it has a touch sensor on it, which was a little bit of a trick. It's all written in assembly. It has this giant battery on it. It gets you stopped at airports. It's hard to put on a coat over it. But at the same time, I was pretty proud of it when I made it at the time. And I think I probably sold maybe 10 of these, for like $100.
And it was 7 years ago.
I was geeked. I was
Yeah.
so excited. I was like, I've made it. I'm
Yeah.
selling a thing. And it was
They're
very
nice
exciting.
watches.
Thank you. I'm fond of mine. There's not that many in the world.
I like
so-
how there's just like the other side, the ribbon is sort of like spliced up a little bit.
Oh yeah. Oh, there's probably like tape and goo and crap all this. The Velcro never worked particularly well. That battery's riveted on. The band is actually so this thing is a giant block of casting urethane, which means that you can't repair anything inside this.
It also might not break though, because it's in there.
This one went through. I didn't know what this is an early experience with casting for me, and this one went through some thermal stress. So there's actually an LED in here that's intermittent. If you cast stuff in a giant block of plastic, and you don't have your coefficients of expansion and stuff worked out, you can crack through whole components. And so there's one like the twos place in the hours is sometimes a little iffy. So you'll be like, is it 10 o'clock or is it 8 o'clock?
Yeah.
That's a little binary joke. So anyway, anybody got that? Call me on ham radio.
All right. So
All right,
what-
watch.
Yeah. So that's to watch.
We'll
him.
watch.
next?
I don't know, man. What do you guys want to see?
What's
There's
this big thing here with the
Well,
bed?
this big thing or
Yeah.
that big thing?
Both. I don't know
Well,
what it is.
let's go to the box over there.
Yeah, what's this box?
The ancient
Yeah.
thing. So I actually never show this off. I brought this here because
Yeah, what
I
is this?
I was ready to get on a high. This is another terrible ancient prototype from my youth. And
This is gigantic.
It's gigantic.
Yeah, maybe
you
can
can't
help
even
him
see
with
it.
the
All right.
gooseneck there.
Yeah, maybe.
I don't know if you're gonna get that.
Yeah.
We can just
Maybe-
hold it up in front of that camera.
Yeah, maybe because it is really big. It's not going to
Yeah, I
focus on it.
actually think it'll be okay. Let me just go around the
Alright.
side. I'm gonna.
You
If
think
only
so?
there were an engineer on this show.
Oh,
that
that's
could
not so
figure
bad.
this
Okay, yeah, wait. No, it's fine as is.
Yeah.
All right,
All right.
sorry. Usually it has like focus problems when it's too close. Okay.
So-
So what is this?
This is basically like, you know.
Wait, can you turn it around? Because I think
Yeah, it's
the
upside down.
printing is upside, yeah, it's upside down.
This is
Yeah, what is going on here?
so this is the first RFID thing I made. It's an analog RFID circuit, and it's a jewelry box, and I made it for an art show, which shows you how far I have come because I would never ever do that again now. And
You got a transformer power supply in there. That's
giant
this
many
is
watt,
an old project.
a many watt power supply, and it's because there's these RFID coils. So, all right, so this is an LC pair, right? The idea is, I'm gonna just pretend
Squelch
like-
that.
All right, so the point of this thing is it's the goofy musical instrument that I made exactly $0 on, and all of the stuff in here. What I really wanted to show off, if this thing can see it, is that spaghetti mess of wiring that's in there. And
So it detects the LC coil and then it makes a sound, or what does it do?
yeah, it's got 8 analog instruments. So you can see right here. There's a row of screws here, and there's another row of screws over here, and they're tied together with these alligator clips. And the idea is that you have this goofy etched surface, and you have a bunch of LC tanks in here, and you move these LC pairs around, and they get picked up by these coils and generate a control voltage which affects these different 8 analog instruments. And this thing down here is an 8-step sequencer, which is all 4000 series logic, and which you can randomize by the proximity of a ring and blah and blah and blah. But the point of this was that, like,
It's all analog.
to me, it's analog and digital, but
There's no digital. Oh,
there's no
74.
process. There's no processor.
Yeah, this is. I mean, you could build it with transistors.
You could build it with transistors, yeah, and there in fact are some transistors in there. But the point is that for me this was like love at the time. Like this was what electronics was about. And this is like when I still think, and this is I think this is a good thing and a bad thing. When I think of getting into electronics, this is what I think of, right? Like I
You're
think
like,
of
oh, it's crazy wires.
yeah, you can. I couldn't.
Transformer that could blow your hand
I
off.
can't afford wire. Like spools of wire are expensive, right?
Yeah, is this a telephone wire?
It's telephone wire.
You
It's
got
a
this-
gnarly bag of telephone
You're
wire.
going
that
to
I
like the
stripped all wire.
9X and like grab like a.
Nobody was using them anyway. So yeah. So yeah, all that stuff was hand wired. I did not make a penny on this thing, and it was like, you know, I couldn't. At the time, I not only was ideologically against programming because I was stupid. I also couldn't have done it to save my life. So anyway, I brought this because it's like
I like it though. I like the wire
Yeah.
mess.
I will keep this forever.
And I like
will,
the Radio Shack.
yeah, tons of Radio
power
Shack
supplies.
perf board, tons of like you know, you see like trying to make all these like wire tied.
One of the coolest things I made was an old analog Nixie clock, all
Yeah.
74 logic. I like blew it up like 3 times.
Yeah,
You
exactly.
have the voltage doubler because it's just like
Yeah.
120 volt in, and then you double it, and
Yeah,
you're just
yeah.
like, I hope nothing touches it.
Yeah, exactly. Yeah, this thing is also good for heating your home. So anyway, I brought that because I don't know. I meant to make some point about it. I'm not sure I did.
Next up.
Next up,
All right.
what
So
about a little board?
little board.
Okay.
How about this one?
How about that
Yeah.
little board?
All right. So this is.
You can move the. There you go.
So this isn't. This also has nothing to do with work. So I don't know. I don't know if it was clear from talking about toy stuff. But I moved to New York and I became a contractor, which means that I basically am like I'm a hired gun, right? So people call me to finish their projects for them, basically.
Yeah.
And it means that you get to build a lot of stuff, and it means that you get to move on from a lot of projects. But it also means that you are typically under NDA and can't show off the stuff that you actually made for
Yeah.
real. So a lot of this stuff is stuff that I made for fun, which is still real, I guess. Anyway, this is a high-speed DAC and amplifier board for driving a vector monitor.
Oh yeah, you were doing the Vectrex stuff.
It's not Vectrex.
No, but you know what I mean.
I mean, I know what you mean. I don't agree.
I don't know the other. Vectrex is what, the game itself.
Vectrex is the gaming system.
Okay.
This is based on.
And that can die in a fire. This is just for generic vector.
Well, this is to drive the Electrohome G05 monitor, which is the monitor that was in Omega Race and Asteroids, and is like the big, crazy hot X-ray producing monitor that was in all those old.
Like Total Death.
The one that like you can, if my skin looks a little transparent, it's probably because I was working on this thing.
I did once play a real Asteroids game, like an original. I went to this old arcade. I don't even remember when. It was like in Maine or something.
I mean, you have many things in your life right now, but should you have the time and inclination, you owe it to yourself to play one of those games because they look
They are incredible. Original, and it has the. It was really funny because when you play it, you don't realize that the original, it was like a black and white screen, then they use a silver mirror to reflect the game play on it, because like there's all the background and stuff.
Are you thinking Battlezone? You're thinking Battlezone.
Maybe it was Battlezone, but they had no. It was not that. It was they had a translucent covering on the TV. It was a red and green.
Battlezone.
Was it Battlezone?
Yeah.
Okay. Because there was a couple of vector-based games, and I was like, I remember playing them, and I was like, oh my god, this is totally different than I
The
thought.
sights in Battlezone are red because they have red tape on it.
Yeah, there's just like red tape on it. There's no color.
Yeah. Anyway, so this thing, basically the idea is one of my buddies, a couple of my buddies and I decided to try and work on a new vector game. Because the idea is that monitor looks fundamentally different than anything else that's been made since. And it looks really cool, but it's always been run with these it was run with the processors and the math chips available at the time. So doing anything in 3D was really, really difficult. Like, anymore, that sort of math is trivial. But getting a computer or an FPGA or something like that to talk to one of those monitors is actually, it takes some doing. You can't.
What is it, like a high voltage?
Well, the monitor itself is a high voltage device, but
the voltage in.
Is this the right photo that I have here of it?
Yeah, that's it.
Yeah.
So that's it. That's an early prototype of the game, and you can see our. So that world is actually 3D, right? That spaceship is 3D, and if you blow it up, it comes apart into 3D bits. And that was sort of the goal was to make a demo, basically, of all the cool stuff you could actually do with this monitor.
Did you take this around to like demo shows?
Not yet.
Because you get all the checks.
I'm saying. So anyway, so this is the amplifier board. There's an FPGA board, a Xilinx board that attaches to this that Andy wrote all the code for, and then this board runs off the supply that's in the monitor.
So what's the 3 channels? It's RGB. No, that's not RGB. That's
X, Y, and Z.
Z.
Yeah, Z is brightness. Z is what vector people call brightness.
Okay.
There's a lot of confusing mix-ups of X, Y, and Z that happen about every stage of rendering in a vector game.
I know, like Z means like it's like, oh no, that's the alpha channel. Okay, what the fuck? All right.
Anyway, so this thing talks to an FPGA and it draws at about 20 megahertz and it draws 15 to negative 15 volts on all those channels.
Oh, that's not so bad.
If you want it to be straight.
So you have to tune it.
You do a little bit of tuning. So those are the pots that you see on there.
Yeah, that's a good question. How do you calibrate on the monitor? Do you make like a grid and then you try to calibrate in software?
Yeah. You calibrate. There's a bunch of monitor controls, and then you calibrate brightness in software. So you're like draw a gradient, and then you pick minimum brightness and maximum brightness, and then you crank gun speed. So the brightness has to do with how long the electron gun stays on any given point. So you can. Basically, and the idea is the faster you crank up that gun, the more stuff you can draw on the screen, right? So you really want that gun flying. But
because like that was a pretty impressive image. Like that's a lot of lines.
It's a lot of lines. We can with the current generation we can get to 400 something lines on the screen. I don't know how well Asteroids can do. I met one of the guys from Atari who worked on the math box in Battlezone, maybe, when I was out in Silicon Valley the last time, and he was much smarter than me.
Why did they decide, do you think, to do vector instead of raster? Just for the look? I mean, I can't imagine.
I have to imagine it's because they could get effects at the time that were difficult to get via...
Movement was smoother.
Movement's smoother, and the cool thing is some of those games actually have an analog vector generator. So they actually, there's like this right now, the resolution of this display is
oh, that's true. Like you can actually do stuff without having to...
You don't get jaggies.
Yeah,
right?
you don't have to raster it.
And you got mad jaggies on all games from that era otherwise.
Yeah.
So like...
Because they couldn't do more than like 120 by 60. resolution.
Nah, I don't know what the resolution was on a lot of those games. I'm sure it changed very rapidly.
Yeah.
But you got a different effect, and my guess is that it was somebody's idea of getting some sort of competitive edge by using a different.
Also, like the blacks are really black. They get really.
Blacks are really black, and the whites are really white, and you get all these different. You get trailers on stuff all the time where if you have a blazingly white dot on the screen, it stays there. There's persistence on those phosphors.
Yeah.
So you can end up like when you die in this. We've been working on drawing a skull, but you draw it really slowly. So you draw this
so
skull, and it's like,
fake.
and it's totally awesome.
Okay.
And you get a radiating too, which is.
All right.
Okay.
So let's keep moving along here. You got a couple more things.
So how did you get the monitors though? Are they just on eBay or like luck?
Yeah, getting the monitors is hard. This is again in my history of great commercially viable products. This is another.
But like one person will pay $50,000.
There's 7 of these.
If you can find that person, if you're out there,
JWZ was trying to fix his vector machine. You should talk to him.
Okay.
There you go.
Okay.
He sold out a long time ago, so maybe I'll
So I have some video synthesizers, and I have.
Yeah, let's show a video
show the
synth.
video synth because that
All
I
right.
have a photo of. That's the one that was at Maker Fair, right?
Yeah, this is the one that's a
Okay.
Maker.
This
Faire.
is like banana plug.
Yep.
Yeah. So let me
The
show.
light.
Let me show what it looks like. So here's
Yeah, and then maybe
here's
we'll
you and Lamore here with the
Straight cheesing.
yeah. with the,
Yeah, that's great.
and then
Remember,
here it is.
remember like, oh, who's this asshole? Like, it's
Yeah.
really nice.
Here it is, and then all right.
All right, so you got
Okay.
this. You got this
So
thing.
yeah. So I got this thing. Here, I'll turn it on. Like it'll matter.
Oh, the LEDs are on.
Now it has lights. So this is.
It has NTSC out only or what?
NTSC, yeah, and it has S-video also, but the color encoding is still NTSC.
I
It's
could
just-
get in to see a TV while we're showing a video. Do you want?
I used one of your.
Why don't you hook it up? Do you want me to hook it up?
It's gonna take a hot second to do.
Yeah, it's fine.
All right.
I'll do it, or you can do it. You can talk. You show me where the TV is. and I'll
Yeah,
play it.
what we can
Okay,
do.
it's in the Pelican case.
What we can do, Lamore,
Yeah.
during the wearable video,
Yeah.
we can hook that up,
Yeah.
or you can just.
No? Okay.
Yeah, we have a little bit of time.
Uh,
So,
You describe it while I hook it up. I guess
yeah.
not.
Well, you guys can imagine. You
Okay.
can imagine.
It's got a lot of banana plugs on it.
It has a lot of banana plugs on
What
it.
are these all about?
So,
What were you thinking?
what was I thinking?
What
So-
were you thinking?
So this is an analog video synthesizer, right? There are lots of analog audio synthesizers in the world out there, and the idea with one of them is that you basically take a bunch of fundamental waveforms. You take a lot of saws and triangle waves and square waves, and you stick them together in various ways, and at the end of it, in theory, a musically useful thing comes out at the end.
If you're lucky.
If you're lucky. A video synthesizer is a similar idea where you take a bunch of sines and squares and sawtooth waves and whatnot and audio, and you stick them together, and at the end of it, hopefully something that looks like unicorn barf comes out. And that's what this does, basically. So these different banana jacks in here are all patch points. And if you get into dorky synth history, you'll find many polemics about what sort of patching system is the one
What's
true
socially
patching
acceptable?
system.
Yeah, it's okay.
So
which one
this
do
is-
you have?
This is like the pinky extended like Germanic patching system. This is the like money is no object, like let them eat cake.
Yeah, you got like every single test point there.
It's not that there are lots of test points. It's that this format is esoteric. But the thing that it allows you to
Looks
do,
esoteric.
the thing that it allows you to do is to, like if you had an 1/8" patch cord. The reason I like it is because you can stack a banana plug, so you can have as many things plugged into something as you want.
Okay.
The idea actually with that thing with all the screws on it is the same concept. You
Yeah.
can patch 3 things into something and then take the one out in the middle if you want. If you cared about patching in the first place anyway, which is antiquated and stupid, right? So
You've got plenty of knobs on there. Why do you need to patch?
right, you even have a processor on there.
Oh, man.
So
Do you have any JFETs on there?
yeah, I do have JFETs on there. I do have several JFETs. There's
All right.
JFETs in the so like the cool part of this thing is down here. That's actually the color synthesizer, and that's what takes whatever.
What do you use to generate the color output? Do you use like the ADS 7752 or
I
something?
most certainly do not.
You do not.
So that was like part of the design.
Why don't you tell me why you hate the ADS 7725?
You're thinking the 8724, 8725?
87. I thought it was. Oh yeah, is it 77 or 7?
It's a 724 and the 725.
Yeah.
If you're thinking of the one that I explicitly did not want to use.
But it's so nice. You just give it analog in and it works.
Yeah, what did JFK say? He was like, "We do this not because it is easy."
All right, so you're like screw that. I'm going to actually generate the Syntan, whatever,
Yeah,
shifted
Nad
sine wave.
Syntan in there.
Okay.
And there's there are lots of ways to generate color. This is the 6th revision of this thing.
You could have just used the 8725.
Well, yeah, you know, you asked me what was on the 1st revision.
Okay.
The hard part really is the color generation part. So if you talk about video, one of the fun things about generating this kind of stuff, you know, if you want to get all pretentious about it, is the way that you can think about light in different ways, right? Like if you're printing inks, you talk about CMYK, right? If you're talking about lights, you talk about RG and B. You can also talk about alpha. You can also talk about hue, saturation, and luminance. And you can think about these color spaces in different various ways, right?
Yeah.
So you can make them as trippy and abstract as you like.
Yeah.
This particular synthesizer, I'm partial when you're making something which doesn't ever have to look like anything twice.
Yeah.
I prefer hue, saturation, and luminance because
That's the most fun to tweak.
It's because
Because you get what you expect.
well, it's
You're like, oh, I want to turn it up more. You actually get, like, you can do, like, saturation is more.
well, the hue part is the part that I like, right? Because you when you're screwing around with it, you don't get spots of red and green. Like, it never looks like a Christmas tree. And B, the color space is thought of in a continuous way. So you have 0 to 360 degrees of color rather than fading in different quantized.
Because otherwise you have to fade in and fade out. And
Yep.
with RGB,
Yeah.
it's not as elegant.
Yeah. RGB is very useful.
It's great.
But it's not what I did for this. So basically, you have to take these control voltages in. You have to make hue, saturation, and luminance out of them. Without getting too deep into how NTSC works, luminance is easy. It's basically just a voltage.
Because it's backwards compatible with black and white.
Yeah, exactly right. Hue and saturation are harder. They're relatively high frequency. They're at 3.58 megahertz, which is not crazy, but you can't use an LM324 to push those signals around. You also have to be careful about impedance because it's really easy to attenuate all that stuff. And if the trick about
It has to be in a narrow band of voltage too. They're very picky.
It's very picky, but you'd be surprised actually. Like TV is well-traveled territory. You know, like a VCR or an analog TV is real forgiving about what you put in. Modern digital projectors are not always, and in fact, traveling around with this, like one of the things about not using like a 724 is, you have like. This has like your Todd Bailey concept of sync on it, which is pretty good. It's pretty close to the NTSC spec. It's not exactly right though. So
did you like even odd line stuff?
I don't interlace.
See, that's a pain in the ass.
It's a pain in the ass. A and B. Like a lot of old. Like I don't think that I'm not sure. Like a lot of old video game systems don't do that explicitly, and if you don't interlace just right, you get all kinds of jitter and stuff.
Yeah.
So the first time around, I was like, let me try it without interlacing. So I did. It worked fine, and I was like, done.
Done. Yeah.
Right, but then you take it to some real fancy video house, right, and their very fancy thing is like, what's this? It's not really NTSC. So I've actually been bitten by that by my. So don't be lazy. Always read the data sheet. Anyway, hue, saturation, luminance. I can keep talking about that, or I can move on.
Let's go to the next
Let's
one,
move
and
on.
then we'll kick into the rest of the show.
Okay.
Sure. I guess. So that other thing is another video synth. That's probably.
All right, let's just show that off
Yeah.
and then
All right.
move on.
And then there's like the fancy things.
Yeah,
Yeah,
bring
but you
those,
can't talk
bring
about
those
it.
two up, and then
All right. So
there you go.
Okay. All right.
let me bring the like what's left. So
Just toss it on there.
just toss it on there. So this is another video synthesizer. This one uses quadrature amplitude modulation. This one's the most expensive of all of the video synthesizers because it uses a lot of fast multipliers to generate video. That one is much better because it's much cheaper, which is a victory in engineering terms, right? But this is just another video synth, basically. This is the Mark V. This is an example of the kind of development board I would actually use for real work. So it's difficult for me to talk about real work stuff because there's usually some sort of contract with someone who is not as open-minded about.
But what is this like? I can look at this. This is an Atmel
Is that no radio?
radio. So this is what like one of their RF chips, ATRF chips.
Yeah, it's
or?
an ATRF86.
Okay.
So
and
this
then
is
this part, I'll read this off so you don't break your NDA or something. So this is an at X Mega something 384 B3. I don't know. I don't know. I can't. No, it's really hard to read. You know, they don't print anymore. They laser it on, so you have to like get it quick.
Yeah, it is hard to see. But this is the example. Like this board, I did not make for a specific client. This is a board that like I do. Like if I get a toy contract or a small run of something, it's handy to have a development platform in house. And
This is a chip I like. This is a chip I use.
the chip I like, the chip I use, it has flash on it. It has an audio amp on it. It has lots of ports broken out. It has like tons of the libraries that I've written. For
That is handy if you're a contractor
toy.
to have your own like dev
Yeah.
board.
So this is the one that
Todd Bailey light.
This is the it says Todd Bailey light somewhere on it. Yeah, so it's an X-Mega based board, which I've been using a lot lately and which I like pretty well. It has like fancy. It has a silicon oscillator on it, which is my jam.
Very nice.
Yeah.
It's pretty sweet. You can just
Yeah.
like you can connect it up to USB, and you don't need nothing.
Don't need nothing.
You don't even need like those 22 ohm resistors. You do not need nothing.
You do not need a nothing, and
And they're cheap too.
they're pretty cheap.
Let's look at this last board. This is a monster board.
All right, let's look at
Yeah,
this one.
and
Let me keep my
then,
thumb over part of that while we're
Yeah,
doing
look
it.
at that.
So
You
this
can't
is
see almost anything on there.
All right.
Oh, the logo.
yeah. So
Yeah, it's right there.
so
Okay.
this is the.
This is a contract that you made for a company that should not be named.
So this is a board that I made for actual work, right? And this is a lot
That's
more.
a gigantic cap.
That is a gigantic cap. This board was in a harsh environment, and it did not always get consistent power. So it had to weather momentary power outages a ton, which is why it has that giant cap on it. There's still filth on it from coming out of a working environment. And this is an example of with like this thing, right? You see it, and there's no solder mask, and there's no silk screen, and like
It's cheap.
it's cheap, and if you like spit on it, it will break. And this thing is an example of something which I've tried very hard to make it such that if you spit on it, it won't break.
So it's conformal coated.
It's conformally coated.
There's
yeah.
like redundant power supply management stuff. Or
Yeah.
whatnot.
There's the code is a lot more careful about dealing with any sort of fault condition that it might encounter. There's that big ass board stiffener that's on there, such that you can handle it like a normal human being who's not being precious about it can handle it and treat it poorly, and it'll still work. There's a resettable fuse on there for dealing with power supply problems. There's all kinds of transient voltage suppression all over it for dealing with crappy environments. So this is the kind of stuff that I would actually do more for.
Crappy power supplies is it's a really common issue.
It's real.
It's a
Crappy
real.
power
It is
supplies
a real
are real.
problem.
Yeah.
And a lot of people, it's like they don't realize when they get into finally making a product. I'm like, your power supply is going to suck. You just have to be ready for it.
And this is the example of a board where there's tons of different components on it, right? So there's these big motor drivers. These things here are for driving motors, and they're not small motors. So tons of juice gets back on.
What's your favorite motor driver chip? Or you just spec them as you need them?
I spec them as I need them. These are BLDCs on here. I'm using an Allegro part.
What's the how much does that cap store? What is it?
10,000.
10,000 microfarads.
Wow.
Yeah, and that's also spec. Like this thing, where it lives.
Wait, hold on. You gotta focus. Hello. Oh, it's out of focus. Yeah, there you
All
go.
right. This thing where it lives, it has to be installed and stay working for sort of a long time. So that takes into account the fact that it's going to be freezing a lot of the time where this thing is, and it's going to have to last for a bunch of years. So it's better to just make it a little bit bigger.
Yeah, sure.
Yeah, in this case, it's better to make it
You're
bigger.
not paying for the bomb.
Hey, so all right. So this is what I do for a living.
All right. Well, thank you for showing us all these demos. This is fantastic. This is good
All
stuff.
right.
We don't get a lot of analog synth and stuff like that on the show, so this is really good. Okay, so we have about a little less than 20 minutes left in the show, so we're going to zip through.
Let's zippy zip.
We're going to zip through a lot of these things, so I'm going to go through this very quickly. So big news this week in the world of open source hardware and Arduino. As everyone has saw, there is a new, they're calling it an Intel-based Arduino, the Galileo. So it's just this monster Linux board with, comes with a free little
That's
astronaut.
a beast.
Yeah, it comes with a free little, and it uses their Quark processor, their Internet of Things processor. So no pricing or availability known yet. This was announced at Maker Faire Rome. It may use Arduino shields. The libraries may work. Lots of unknowns.
Right.
I have no idea. I do not have one.
Yeah.
I do not know when they will be released.
Yeah.
I do not want to program one in assembly.
Yeah. and
They probably don't even release the assembly.
This is Arduino's second Linux-based Arduino, and as more information comes out, we'll
let you know soon as we
post
know.
about it. Yeah.
We don't know.
Next up, there was a collaboration. Another Arduino was announced, the Tray, and this is a BeagleBone and a Arduino kind of all in one.
Whoa.
And yeah, this is
Some Wonder Twin powers. In there.
yeah. Wonder
It's got
Twins.
audio, like 4 USB jacks. It's got a USB hub on there. HDMI looks
Yeah.
like. Yeah, there's
Yeah.
there's like XB socket. There's just like a whole bunch of
So
stuff.
on one hand, it's really exciting because now there's multiple Linux boards that you can program somehow with an Arduino. On the flip side, these are all going to be obviously expensive in
Right.
terms of like more than $50. And we'll see. The Arduino, when it came out, was getting away from the giant expensive dev boards, and now they have to have a Linux board, mostly because of like Raspberry Pi. I'd say like that was one of the
Right.
reasons. And we'll see. So the Intel one, there's the guessing. They're saying $60. The BeagleBone Arduino
Probably
one.
like I'd guess like 70,
Yeah.
60 to 70.
and then Raspberry Pi.
It depends on whether like TI subsidized the chips and stuff.
Yeah,
Like that.
and that also seems to be something that's kind of returning. So before you'd have chip companies making these dev boards.
and
Atmel
they would
didn't-
pay for a part of
Yeah,
it.
Atmel didn't
Right.
make the Arduino.
Right.
You know, they had their own crazy big dev boards.
They had the butterfly.
And
They had the butterfly.
Broadcom.
They still do.
The dragon.
the dragon.
Broadcom has a connection with the Raspberry Pi. They make the chip. Now Intel has their Galileo, and TI has the TI one. The tray is interesting. It's a 1 gigahertz processor, and then they have a 32.4.
They have an Arduino glued
and,
onto it.
and then Arduino is basically physically on there. So we'll see. This is lots of things are happening in the maker world. Pack of the mailbag. Here we are. This is our little yeah.
How many bytes in that?
Yeah.
we had a naming contest.
This is from Andre. I have to tell you that I
Packet one.
purchase electronic goods from many other businesses, both here in South Africa and other countries, but you are by far the most efficient when it comes to processing and shipping an order. Thank you. It's an absolute pleasure. P.S. Your tutorial's the best I have seen.
The
Yay!
Adafruit Kool-Aid is delicious.
Yeah.
Drink it.
Adafruit learning system. I'll go through these really quick. So over 322 tutorials or more. We have a lot of exciting stuff. We're just going to go over what these are real quick. Matthew Bargatti, one of our favorite artists, posted up his flexible robot tutorial. So you can make one of these if you want. And never need to go out again. So that's his...
I think it just looks cool. It's
Yeah.
like pneumatic
Yeah.
robotics is neat. Nobody really does pneumatics.
Yeah. Next up, we have how to run Minecraft on the Raspberry Pi. We have an excellent tutorial from Paint Your Dragon, Phil B. And this is a very cool little Gemma project where you can do a little Space Invader thing. Beep, beep, beep.
Yeah, pick your little Space Invader pendant or pin or something. A lot of people want to build these little mini matrices, and this is very easy.
Yep. Next up, we have Noobs. This is how to install Noobs on a Raspberry Pi. We have a couple Trinket tutorials. This is from
It's a humidity
Mike.
temperature sensor.
Yeah.
Works great. And this is same thing, I think.
Yeah, that's the fritzing. And then we have a little...
a little sonar
one.
distance meter thing.
Yeah. And then we have Wearable Wednesday. On Wearable Wednesday, all the things in the world of wearables. This week, we're celebrating Electronic Halloween. So take a look at all of the projects every single day. This week, we debuted...
Does that mean that chip is broken?
yeah, look at it.
No, it's just gone.
Aw, yeah. We debuted your own superhero power plant project, and here is a video.
Halloween is coming up, and the next Comic-Con is always just around the corner. So you should channel your inner Tony Stark and build a wearable, glowing reactor. It goes great with your elaborate Iron Man costume or just under a white t-shirt. The circuit uses an Adafruit NeoPixel ring and Gemma to backlight some laser-etched acrylic. You can find the files on Thingiverse. Etch 2 pieces and color one in with a dry erase marker to block the light where the etching is. Stack them for a dimensional effect and add copper wire to look like coils. We diffuse the light with a bit of tracing paper, then attach the circuit to the face with glue. Strap it to your chest with a piece of elastic or build it into your Halloween costume. And you can follow our complete guide for this project on the Adafruit Learning System.
Yeah.
What are you building for Halloween this year? Share your projects with us by using hashtag #ElectronicHalloween.
And that was Wearable
That's
Wednesday.
a fun project. A lot of people have been asking, like, how do I
Yeah.
make my own Iron Man type stuff? And so
Yeah.
this is really easy. There's almost like no soldering
Yeah.
involved.
Follow up on Thingiverse. You can see Becky here. All the code is available, and we're still open source, Todd. You've known us forever. We're still open source. We still think it's a good idea.
It's because it is.
Yeah, we still think it is. Next up, 3D Thursday, just a quick programming note because we're doing a lot of stuff for the month of October. We're doing a weekly hangout with people around the world, and it's all focusing on the folks that are printing prosthetics and helping people in the world who maybe don't have access to prosthetics and how we can make them better. So one of the projects is called RoboHand, and this is kind of neat when you tilt it. So if you're missing a hand and you move your hand forward, it'll grip. So we had a fantastic first meetup. It was on Google Hangout. We had Michael Curry from MakerBot. We had a couple people who are actually using these, and then we had Evan, one of the co-founders of RoboHand, and Molly Stapleton from the Lucky Finn Project. So really cool stuff. If you want to get more involved and you want to do cool remixes and hacks and mods, we're thinking about making a 3D printed prosthetic that helps kids who maybe don't have a hand to play video games.
Yeah.
So like it'll actually like play Xbox and stuff like that. So it'll be an Xbox control using maybe our Bluefruit.
Yeah.
So that's our month-long effort. Google is helping us promote this. This is some of the graphics they sent us, and then here is the hands that you can see here. Okay. Before we get on to new products, the code is PowerGauge. 10% off everything in the Adafruit store. It's in stock. Play data. New product time.
It's new.
Yeah. All right. So first new product, you can sign up for this. So we're going to have the new 3D robotics UAVs. This is the Iris. They're on their way. These are the kind of ready to fly out of the box from our friend Chris Anderson. Chris Anderson, who was the editor-in-chief of Wired, who quit to then start his own electronics company.
Awesome.
After talking to Lamore and seeing that, hey, I want to run a company too. Just bagged $30 million in funding for DIY drones, which is now 3D robotics. Oof.
Booyah.
Yeah, intense. So this is his new product that's coming out very soon. We hope to stock. Next up, this is just a quick one. Google has their own operating system that sits on top of the Raspberry Pi called Coder. It teaches you HTML5 and all sorts of other things. We worked with them, and we have the official kit.
Yay.
So if you want to learn programming, like all the fancy
fancy.
HTML5 stuff, they have a...
Yeah, it's like Java. You actually learn to program. It's like JavaScript, HTML5, CSS. So you actually get to do a lot, and it's all in the browser.
So we have a pack, and the card is pre-burnt, so you just pop it in and go. All right.
Okay, we've got some telco splices. These are often used for telephone wire, but since a lot of people use 22-gauge wire in their projects, I was like, this is pretty handy. You don't want to do splicing. This is a wire tap. So what you can do is if you have a wire that already exists and you want to tap into it, you snap this over, and there's little teeth inside that will cut through the insulation and grip onto the wire. So you can use this to, for example, tap into this yellow wire and for the red wires. This is
that's tight.
Yeah, so this is kind of handy. And we also have a three-way tap. And this one lets you tap 3 wires at a time together. So it's called a butt splice. So it splices them together, and again, you put the 3 wires into the slots.
What gauge does that have?
This is 19 to 26.
Okay.
So 22 gauge basically works really well.
Cool.
That's what we use. And here's them, and yeah, they're used for telco stuff. And so I was like, well, this will be good for hobbyists. They have a little bit of like a silicone jelly in them to keep the splices waterproof, so that you don't have to worry too much about oxidization inside or rusting inside. We also have a little mini 2-way splice, which is just smaller, so it might be good for smaller projects. And all these come in a pack of 10.
Yeah.
Handy.
Those are cool.
And
they're useful.
A lot of customers also suggested these to us, so...
We did get a lot of suggestions to please carry
we're
these.
like,
So I was like, okay.
Yeah, we're like, okay.
So you can see a little bit of the jelly in that photo. There's a little bit of the shininess. So that it doesn't like affect the wiring. It just keeps it from water coming in. So they're meant to be used outdoors.
And then next up, this is from our friend Joe Gran, the J-Tagulator.
Check out that pink mask.
That's fly.
Yeah.
Isn't that fly? So the J-Tagulator, I think it's actually faster.
Oh, the photo looks better here.
Yeah, the photo's fine because we don't have it all the time. So this is a USB device. You can see on the right, there's a USB port. And then it runs like there's some chip on. I don't know if it's a propeller chip. Yeah, it's a Parallax propeller chip. And then a bunch of voltage buffers. And then on the green strips are where you actually connect the wires. So what the idea behind this is that it will auto detect a JTAG interface. So if you get a a Wi-Fi router or something, and you're like, I know that there is a JTAG interface on here somewhere because 99% of dev boards in the wild or products in the wild have a JTAG interface somewhere for programming, but you don't know which test point it is.
Right.
You just find the power and ground test points, which hopefully you can figure out. If you can't, I don't know what to tell you. And then you can connect every other test point you want, just solder little wires and connect them to the green terminal blocks.
Have you put this through its paces?
I have not,
Okay.
but I trust Joe Grant because he's Kingpin and Kingpin's a pimp.
It's pretty cool.
It's pretty cool. No, he does good hardware, and he
Yeah.
actually got a cool grant to do this, and he showed demos of this at DEF CON.
Awesome.
So I was like, this is pretty cool.
Okay. All right.
No, this is like
I
this
see
is,
where he's coming from.
This
Okay,
is the
cool.
real
All right,
thing. This
awesome,
is like
awesome,
this is.
awesome.
And he's been working on this for like a year or so. I remember
Cool.
he was talking about this, and it's cool. And he says he uses it because he's actually doing a lot of reverse engineering, and it's a beautiful board.
It is a very
So I mean, it just takes a couple of minutes for it to like cycle through, but it'll tell you like, I mean, it does like the basic JTAG. I think there's like an initializer query, so it just does that, and all you have to do is just, it has like some basic voltage protections, but
Right.
just you just got to make sure that you use a
Yeah.
3-volt. It's like just 3-volt logic.
Beautiful layout too. Like,
Yeah.
Yeah, it's
really,
a real pretty board.
nice.
That's
That is
a pretty-
very pretty board.
Yeah.
Yeah, that's where you got that pink mask. I'm pretty sure it was made in China, but it was assembled in the U.S. at Parallax.
Okay, and then next up we have some new Adafruit products.
Yes.
First one.
This is a very simple breakout. It's for the DS2413. We have one-wire temperature sensors. This is a one-wire switch, so it uses one wire. You can chain as many as you want on a single I/O line, and they share the ground, so it's actually 2-wire ground and 1 wire. And then you can control 2 I/O pins. They're open drain, but they can also be inputs. And if you're into one wire, because it's nice, you can have multiple devices on one pin, and they all have unique like 32-bit IDs and stuff. So it can be a handy way if you want to have like a chain of switches or something drivers, and you'd have a local power supply on each one, but you can have the wires be like 30 meters long or something crazy. It's just not very fast 'cause it's
Right.
like this sluggish but effective way of doing stuff. And I mean, it's used sometimes in like home automation and
For
stuff
sure.
because you have one line going through. Anyways, one wire. It's
One
nice.
wire.
Okay, and do you want us to do the stereo thing or the USB?
Yeah, we'll show the USB thing.
Okay, let's do
Do you
USB
want
thing
it
first.
first?
All right, so here we go. This is our new USB power gauge. This is exciting.
Yeah, this is a power gauge, and I was inspired by a couple different projects I'd seen online, including a Kickstarter that had something similar. But I wanted something that was less just like a gadget and more like hacker friendly. So this is designed specifically for hackers and makers. It's open source, so you can modify it. It uses an AT-Tiny 85, and it's got a bunch of Charlie Plex LEDs. One of the things I like about it is I added a serial output. So it has 9600 baud TTL output, which will tell you the voltage and current. You can reprogram it, of course, if you want. There's a standard like ICSP
This is
breakout.
for people who want to see how much current's going through USB for
Yeah.
various devices, and they could even plug in something to see or log it. If
Yeah,
they
you
wanted
can
to.
log it. So yeah, it's meant for, I was actually building it because I was debugging some Raspberry Pi power draw stuff. And the Raspberry Pi is powered up from USB, and so it was like, I didn't want to haul out my power supply, I just wanted to plug into my computer, but I wanted to see how much current was being drawn. So this is just a little power gauge, and every LED lights up for every watt of power that's being used.
Okay.
So, here, really close. So yeah, there's input over here and then output over here, or whichever way you want to think of it. Like I guess current goes this way. So you plug this into, say, like your wall adapter. Here's a USB extension cord. And it's pretty simple. There's a green LED, and the green LED tells you if the voltage is above 4.5 volts. A lot of times, if you draw too much current, the voltage will droop. And under 4.5, a lot of stuff stops working really well. That's kind of outside of the USB spec. And then, like, let's say I want to charge like this. I got this battery pack or something here.
Yeah.
So it's charged over micro USB, and I plug that into the other side. And then all the LEDs light up because this is drawing like an amp. And so you can see it powered up, and you can see how much current is being drawn. And this can be really handy for debugging your circuit or telling how much power something is using, because oftentimes when you plug it into a computer or a wall adapter, it's really hard to get your multimeter in there, especially because it's like there's like the 4-pin connector. So this is designed to make that a lot easier, and it's assembled and ready to go.
And you
So it's
can
pretty easy.
reprogram it if you wanted to do things that are greater than amp, right?
Well, yeah, it handles 1 amp just because there's 5 LEDs, and I didn't like 99% of stuff uses 1 amp. You can plug up to 2 amps in through it.
Yeah.
Because the current sensor will just the A0 output. There's also an analog output, 1 volt per amp. So if you just want to put your multimeter on it and you want to see an analog multimeter, that could be really handy.
We'll report up to 2 amps over serial.
Yeah, I think so.
Cool.
So it's just the LEDs. I'm like, we actually thought about it really hard about like how do you show even more data on 5 LEDs? We decided, you know what? Let's handle the most common case, and then if you want anything more complicated, use serial output or analog output. Just a little power gauge.
All right.
Handy.
Those are the new products.
I use it every day. Oh wait, we have the.
Sorry.
Last
There's
DM.
still one more.
Sorry.
Show that the photo didn't come in, so it's
Okay.
overhead only.
Okay. Overhead.
New products are not over yet.
Not
but
over.
wait, there's more.
There's like a encore. So I also updated. We had a Class D amplifier board in the store, but I actually wanted to make one that was a little bit less expensive. Hold on, this is really dim. Maybe out a little bit. Hello.
What are you looking for?
Yeah, it's kind of hard to see the chip.
Yeah.
Oh, it's so dark all of a sudden. Something needs dark. I don't know what to do. We don't have a picture. Hold on, let me see if I have the plain board. Here, I can hold it up. Oh.
Okay. Well, I was gonna try to grab a picture.
Okay, so we have a Class D amplifier on here with 2 stereo outputs on this side, and then on the input you can have differential inputs, and it's got I've hooked up here to a bunch of speakers. It can do up to 2.8 watts into each channel from a 5 volt power supply, which is really handy. It also runs off of 3 volts, although you can't draw more than like I think a watt or so into 4 ohms. You can do 4 ohms or 8 ohms. It's really good for portable projects, small projects where you need it's really skinny. It's like a super teeny little board, so you can use it in your projects. And you don't have to put the terminal blocks on it. And we also have a little dip switch that you can use to select the gain. It can do up to 24 dB gain, which is pretty loud.
Yeah.
Hurts your ears.
Yeah.
All right, that's new products.
All right. New products. All right.
And
That's
wait,
what we do here.
there's no more.
There's no more.
Okay. We're gonna open it up a little bit for questions. There's a question for Todd right away. What do you think about software-defined radio?
I've seen some great developments in software-defined radio. It's one of those, like...
Oh, here, scooch it a little bit.
Sure. So software-defined radio is really awesome because it's one of those arguments for faster and faster processors, right? Like sometimes for instance, for working on toys, a lot of the time you don't really need much faster of a processor than there was 5 years ago or whatever. Software-defined radio is a really interesting, fascinating thing where as you get tools which are faster, you can start to analyze waveforms in ways that you could not analyze them previously. So
Have you dabbled with any of the RF SDR boards or?
I have one around at home that I think is a reworked Broadcom chip or something like that runs on Linux and has this awesome waterfall display and is this SDR that I've only ever used for ham stuff. But
Yeah.
I have yet to use one for work.
Okay. Next up, this one's for you, Lamore. Will we be switching from the WS2812 to the WS2812B for the Florida NeoPixels?
Don't know.
Don't know.
No decision made.
All right, next up. This is from Bill Hurd, who's
Bill Hurd! Whoa, Bill Hurd, C128 in the house!
He said, I think I met Todd at the Commodore session at VCF East last year. Is that true?
It is definitely true, Bill Hurd, you rule.
Okay,
You're
wow.
OG. You're OG.
All right, next up. Can I conformal coat dip one of the CC3000 breakouts?
Yeah, I think so.
Okay.
Nothing
Can
on it
I
that's
use
moving.
a Bluefruit to communicate with multiple devices simultaneously?
Bluetooth can only do one-to-one pairing. It is a Bluetooth protocol thing. Bluetooth cannot do any kind of mesh networks or point-to-multipoint.
Okay. What is your favorite form/manufacturer for flash memory?
Who's that for?
You use flash memory.
I use flash memory. I used Atmel parts for a long time, and they discontinued them. I use SST parts a lot now.
SST.
Yeah.
Okay, SST is it. Don't use nothing else.
Word?
Okay.
All right.
Next up, Todd, have you looked into or been inspired by old video synths from the 70s, like
Absolutely.
Scanimate systems?
Scanmate, not so much. The Sandine, I think, is pretty cool. The Namjoon Pike stuff, I think, is really cool. Yes.
The other one.
Yeah, the other one.
Okay.
All
Yeah,
right.
a little.
Yeah. The others are fun. The big, huge-ass control panel.
Where can I get something laser cut cheaply? I would say try your local hackerspace. They usually have laser cutters now. Next up, can the Bluefruit do mouse commands?
At this time, we only have a keyboard Bluetooth device. Do not have a mouse yet.
Okay. Next up, how long was the development for the power meter? I think this is for you, Lamar. For the little. long did it take to do?
It's been like 2 months or so, I think, on and off. It takes a while to get stuff out.
Okay.
Also, we had a lot of design decisions, like, do you use like a differential, or like low side or high side? In the end, I went high side.
Yeah.
But like, which one do I do? And it's like, okay, like this or that, how many LEDs, which processor?
I prefer high side when you can do it.
I prefer high side too, but then I had to add the INA 169 because
Yeah.
I was like, to do high side effectively, and also like different connectors and stuff. So it takes like 2 months to get something from beginning to end.
For sure.
Something that's small.
Next up, how much current can I pull from the Arduino pins before I start losing voltage?
From the Arduino, what pins?
From the Arduino pins.
Most digital I/O pins are 20 milliamps.
20 milliamps. Yeah, it depends on how much you mean by losing voltage.
I'd say 20, 25 milliamps.
That's a good bet. That's what's in the data sheet.
Yeah.
You'll see a droop there, but not significant. You'll still have a logic high level if that's what you care about, which it might not be.
Yeah.
Okay.
Don't ever count on the output to be like exactly the same as VCC. It will drift.
For sure.
Next up, Todd, where did you get the idea for Where's the Party At, and what's the status of
Oh
that
my
project?
God. Where's the Party At was a pedagogical tool. It's an audio sampler I built a million years ago. The status of Where's
And you
the
didn't bring it
And I
because
didn't bring it because I was trying to get out
trying
of
to
this.
run
I was
a
trying
bit-
to evade this
you're
question.
trying to run from your past.
I built Where's the Party At originally to teach people about electronics when I was young.
Did people learn electronics?
People learned that they liked Where's the Party At.
Okay.
I think some people probably did learn electronics, and I'm still very proud of that project. Where's the Party At 2 is in active development. I worked on it just yesterday, so stop hating.
Okay. Next up,
Seriously.
what would you suggest to buy for a beginner who has an Arduino and $20? So they have an Arduino already, but what else could they purchase?
A bag of transistors.
Yeah.
I would get a shield.
Yeah, I would say.
I'd say get a shield, like a motor shield or a wave shield.
Yeah,
Is
also
a good term.
LEDs. Controlling LEDs is fun.
A little shield, a couple
Yeah.
LEDs.
Yeah.
Next.
Because you have an Arduino, you might as well plug something into it.
Okay, for the guest, have you ever had to deal with commercial real-time operating systems such as VxWorks? What's your opinion on those?
So I
RTOS time.
I, generally speaking, the times where I've done RTOS-y kind of stuff has all been OSs that I either me or another contractor has had to write. RTOS-y stuff gets into a particular realm of electronics that for a toy it's too much overhead, right?
Well, I didn't even imagine a toy would have an RTOS.
You wouldn't need an RTOS on a toy, right?
Just wait 2 seconds. We'll get to it.
I have not used. Was VxWorks? Was that what you asked
Yeah,
about?
VxWorks.
I haven't used VxWorks commercially. It's cool, but it's not my thing.
Okay.
All right. It's cool, but it's not his thing.
All right. Next up, when we're going to have more Bluefruits in, probably in a couple weeks at the latest.
I think we have on track to make a couple more, but we have to
Yeah.
get more of the Bluetooth. Unfortunately, the factory that makes the modules is on break.
Yeah. Are we going to expand our SDR offerings? So, by the way, we have an SDR.
I have no idea.
Yeah.
We do. We have one of those RTL SDRs.
Awesome.
Yeah.
They're cute. They're $20. You can totally break the law in like less than 5 minutes. just like my gauge for how cool it is, right?
Right. Is it still dangerous in 2013?
Yeah.
Yeah.
It's
All
not
right.
a transmitter, it's just a receiver, though.
All right. Those were the questions. That was the
Okay.
lightning round. Thank you so much for answering all those questions.
My pleasure.
It's that easy.
All right.
All right. Next
It's always
up.
a joy to have you.
Yeah, we're going to
It's
give
journey
away.
here.
This is the prize. This is we're going to give
Power
away
gauge.
this USB power gauge.
That
Lady,
one.
what are the
No, this one's mine.
rules?
It's got the debug header on it.
What are the rules?
Rules are if you've won a fabulous prize, you cannot enter this trivia contest again and win this fabulous power gauge. First person with the correct answer typed into the chat wins.
Yeah.
What's the question?
The question is, we linked to Todd's site in the beginning of the show. What is his site? First person that.
Type in his website.
Yeah, it's pretty easy. You can also
If you
you can also Google you. I think you're the
If
top Todd Bailey at the moment.
if you
so-
like
There's a
Todd, you have it memorized.
Yeah.
Oh my God, you guys are making me look bad.
Well, there's a little bit of a delay, so
okay.
it's getting through the internet now.
Do I need
People
to
are
give away
watching.
free stuff?
Do you have anything you want to give away?
No.
Okay.
No, I got something for free.
All right. Well, it'll be the.
ToddsAwesomeWebsite.com.
My web dot my temporary variable.
Temporary variable.
All right, and it is narrative.com with a 1.
One.
Okay, not the up 1. Congratulations, not the up. Email support@adafruit.com and you get one of the USB power meters.
Not this one because there's a debug header on it.
Power gauge.
Thanks, guys.
Okay.
All right.
That's it for tonight's show. That's what it's like. That's what we do here every week.
It's pretty cool.
It Perfect.
You should come again and be opinionated.
Oh yeah, I'm just.
You are definitely the
just
most.
very beginning to get opinionated.
You're
I'm
the
still
most opinionated of all of our guests. Most of our guests are usually like, well, like, that kind of like
Actually,
all kind of processors.
Here's a good question for the audience. Would you love to see Todd do a series of tutorials on the Adafruit site that had all sorts of opinions about what to use and what ways to learn?
And if you connect the Xeno diode this way, you're a sucker.
That means you're stupid.
We're trying to convince him because we really like his entertaining style of electronics and what he does. And I was at iBeam when you taught a workshop there before.
Yeah.
Yeah, that was fun. You're like, I'm going to teach like op amps and filters in 1 hour. And like everyone knows, like, I don't even know how to sound. You're like, all right, buckle in, bitches.
Yeah.
No.
Poor kids.
No chickening out.
Those poor kids.
All right.
Okay.
That's it. We'll see everybody next week. Thank you so much again, Todd, our special guest.
My pleasure.
Thank you, everyone in the show and tell. Thank you to all the folks. Big night. Lots of folks here tonight.
Yeah, you're like, everyone's your fan.
Yeah.
Everyone's your fan.
You have a follow.
No, and we can tell when it's your fan.
All right, and here is, we have to show a picture of MOSFET because he used to live in the factory, and there's lots of kids who watch the show and they always like to see a picture of the cat.
Mean mugging.
Yeah,
mean
there he is
mugging.
just hanging out. But in the end, we always do our, here is your moment of Zener.